Hello students, welcome back to my class. In today's video, we are going to discuss about the chemical properties of acids. See, in the last video, we discussed on the physical properties of acids. That like studied as all acids have same to taste, and acids when indicator like phenolphthalein is added, it shows colorless. When indicator like methyl orange is added, it turns to red color. And also we studied the metals turns the blue litmus paper into the red color. And also we studied that the acids are good electrolytes. They conduct electricity when they are put into the water. They act as a very good conductor, so they are called as good electrolyte. Well, today in this class we are going to discuss about the chemical properties. Under this, we are going to study about the reaction of acids with that of metals, the reaction of acids with that of carbonates, and also the reaction of acids with metal hydrogen carbonate, that means bicarbonates. And also we are going to discuss about the reaction of acids with bases. And in the next video we are going to discuss about acids when they react with metallic oxide, what they produce. That also we are going to study. See, in this only we are going to study these three chemical reactions. Well, the first one we study first one, that is the acids react with metals. So you take any metal, when the metal react with acids, they produces their salts. Means whatever the metal is there, that metal salt will produces. Along with that, there is a liberation of hydrogen gas. So that is a general form of the chemical reaction of acids with that of metals. So I have taken an example of zinc. I have taken zinc here. Zinc, when combines with the sulfuric acid, it produces zinc sulfate, which is a salt plus hydrogen gas. See, I have written that equation. This is wood equation, and this is chemical equation. Zn plus H2SO4, that is sulfuric acid, and formation of zinc sulfate. See, I said the metals always displaces the hydrogen from the acids. So acid means they must contain H2S ions. That is displaced by the metal, and they will combine with the rest of the part. It produces the salt. So zinc sulfate, and this hydrogen gas displaces outside. So there is a reaction Zn plus H2SO4, formation of ZnSO4 plus H2 gas. And the second one, this is the first one. And the second one, I have taken one more metal, that is magnesium. So when magnesium combines with hydrochloric acid, I have taken here hydrochloric acid, they react with this, and here also magnesium displaces the hydrogen and combines with chlorine, and formation of magnesium chloride, which is a salt. Along with that, hydrogen gas is liberated. And this type of examples is also, this is an example of single displacement reaction that is studied in the first unit, that is single displacement reaction. Example for single displacement reaction is. So this is all about the reaction of metals. So let's do that experimentally. How the zinc react with H2SO4 and produces hydrogen gas. And the liberated gas, whether it is hydrogen, we will test that one by doing the experiment. Let's do experiment, that is the reaction of zinc with that of sulfuric acid. That will be. Let's see that one by doing this.
Now we will discuss. I'm going to do the experiment, that is the reaction of metal with that of acids, or acids when they react with metal, how they liberate hydrogen gas, and that reaction I am going to take, taking an example of zinc react with sulfuric acid, formation of zinc sulfate and hydrogen gas. So let's see that one by doing this experiment. See, I have taken a zinc granules in this. So these are all zinc granules in the small conical flask I have taken, and I have taken a test tube which I kept inverted, and to this I am going to add sulfuric acid. I have a sulfuric acid here. So when I add sulfuric acid, what will happen? It forms zinc sulfate and hydrogen gas. See, I have kept the test tube downward like this, upside down, but here hydrogen is a very light gas compared to air, so that it will not escape out of the test tube. It will be stored here only, and later we will test that by taking matchstick near to this one. Okay. I will add this one to sulfuric acid to the zinc granules. Yes. So when I add this one zinc granule, the reaction starts here. There is a reaction starts. The bubbles are coming. So that is the production of hydrogen gas. I am going to collect that hydrogen gas in this test tube. Yes. See, the hydrogen gas will not escape because it is lighter than air, so that it is not coming outside. It will be stored in this one. When you bring the matchstick to this, it catches the fire and with producing pop sound. So that will be test with pop sound. See the collection of gas in this. Well, let's test showing whether pop sound or not. Okay. So this is reaction is taking place. So when I hold this one, see there is a gas is coming out of this, and this is all of hydrogen gas it is. Still going, sir. Now that will test for pop sound. See. Sir, please. There you got a pop sound. It is because shows that the liberated gas is hydrogen. So one more time you can see. There's gases coming out of this. Yes, you'll see there's a pop sound. So that shows that the liberated gas is hydrogen, and that is an experiment for reaction of zinc with that of sulfuric acid. You take the metals like magnesium. I will take a magnesium in a test tube. See, I have taken the magnesium in this test tube, and when I add H2SO4 to this, they react very vigorously compared to the zinc. See, they are reactive. So how the gas is coming, see, there the reactions takes place, and this I am going to collect. See, the liberated gas is there. I'm showing here with a matchstick. Yes. See the pop sound of this. There. See the pop sound. See, that is shows that the liberated gas is hydrogen, and with this we come to know that the acids, when they react with metal, they produce their salts and the hydrogen gas. This is one important experiment. And now we are going to discuss the reaction with carbonates and reaction with metal hydrogen carbonate. So that we will discuss. We go to the next chemical reaction, that is a reaction with carbonates and metal hydrogen carbonates. So let's see that with we are doing experiment also on this. The first one, the carbonates generally when they react with acids, they produce as a salt, carbon dioxide and water. This is a general reaction of acids with that of carbonates. See, I have taken an example of Na2CO3, that is sodium carbonate. Sodium carbonate, when it react with hydrochloric acid, sodium carbonate, when react with hydrochloric acid, it produces salt. I said salt is produces sodium chloride, common salt, then carbon dioxide, CO2, a gas is liberates, and along with that the H2O, water is produced. So this is a chemical reaction of carbonates with that of the acids. I have taken one more example, that is calcium carbonate. So when the calcium carbonate combines with hydrochloric acid, it forms calcium chloride plus carbon dioxide and plus water. So like this the experiment. Let's we do that experiment. That is the first one, that is sodium carbonate. I have sodium carbonate here. See, I have sodium carbonate. I will take the sodium carbonate in a test tube. Yes, I am going to take a sodium carbonate in the test tube, and I am going to add to this, yes, sulfuric acid I am going to add here. Yes, to this I am going to add acid. When I add the acid, what it should produce? It should produce a carbon dioxide, salt and water. See the reaction. See, there is a liberation of carbon dioxide. So this carbon dioxide, how to test the produced compound, the gas is carbon dioxide. I am going to pass this into the lime water. When I pass into the lime water, see, the lime water turns to milky. So that is the reaction. The same thing for bicarbonate. Take a bicarbonate. So I will show that also. Now only the sodium bicarbonate. When you take the sodium bicarbonate, then the water is to see, the same reaction takes place. There are also salt, water and carbon dioxide releases. So I am going to add acid here. See how there is a carbon dioxide fused. The same carbon dioxide I am going to pass through the lime water. Acid I'm going to add here. So I'm going to pass through. It turns to milky. Yes, the carbon dioxide is coming and it is going to turn milky, right? See, the content is showing the milky. So that is the reaction of acids with that of carbonates and the bicarbonate. So I will write the chemical reaction for the bicarbonate. So that is one, that is NaHCO2. That is, what is the called? Sodium hydrogen carbonate, also commonly called sodium bicarbonate. And this, when combines with HCl, forms NaCl plus CO2 plus H2O. Same reaction process there. So this is the chemical reaction of the sodium bicarbonate when reacting with the acids. So that is the reaction of acids with that of carbonates. And the last one, reaction of acids with bases. So when any acid react with bases, they get neutralized and they produces salt and water. Whenever an acid reacts with base, they get neutralized and produces the salt and water. So that we're going to do that with an experiment, taking an example of sodium hydroxide versus the H2SO4 or HCl value add drop by drop. So with the using phenol indicator, that neutralization reaction I'm going to show you.
Now we are going to discuss the third chemical equation, that is the reaction of acids with that of the bases. Yes, when acids react with bases, they produces. There is a general equation I will show you. Acids when they react with bases, they produces salt and water. Studied in the previous class also. So whenever an acid reacts with bases, it produces salt, and this type of reaction is called as neutralization reactions. Well, so whenever this reaction is called as a neutralization reaction, when acid add to the base, the acid and the base effect get neutralizes in this reaction, so that there is a formation of salt and water. So this is one of the important reaction, and let's we test that by doing this experiment. See, I have taken a sodium. I have taken acid in this bullet, and versus this, I have taken HCl, and in this I am going to take sodium hydroxide. See, I am going to take a sodium hydroxide in a conical flask of about 25 ml. To this, I am going to add phenolphthalein. So you know, on adding phenolphthalein to the bases, what is the color will come? Yes, that is pink. See. So there's a pink color appeared in the sodium hydroxide. See, it shows that it shows the effect of sodium hydroxide. So due to the presence of sodium hydroxide, when combined with phenolphthalein, change. So when I am going to add this one, the acid and base, when they at a particular point, when they get neutralized, at that time the color disappears. I am going to show that one with drop by drop. I am releasing the acid into the HCl into the sodium hydroxide. See the reaction. So slowly it goes on changing its color. So color is going to faint. See, the color is disappeared. Means now this is a neutralizer. Acid and base are both getting neutralized, and this salt and plus water is there. So this is a reaction that is called a titration. I have titrated HCl with that of sodium hydroxide, and this is the neutralization. This is an example of this is a reaction is acid react with bases. So with this, I have completed the reaction, chemical reaction up to this, and two more reactions are there regarding. So one is reaction with metallic oxide, acids react with metallic oxide, and some other reactions are there that we will discuss in the next class. Thank you for watching.